Okay, we're going to continue solving additions of rational expressions. We're going to perform these operations, and in these examples, most of them are going to require us to do each one of the steps of the main process. So we're going to have to factor the denominators. We're going to have to multiply stuff so that we can match the denominators because they're going to be different at the beginning. We're going to have to add the numerators, and most of the times we're going to have to simplify the answer. So make sure you already know how to simplify rational expressions, and you need to definitely know how to factor, because if you don't know how to factor, you're not going to be able to do these exercises. So exercise number 1. In this case, if you notice, they're giving us fractions which have polynomials, right? So we're going to have to factor these two things. That's the step 1. To factor this one, we're going to have to use scissors method, and to factor this one, we're just going to have to guess and use factoring trinomials, right? So I'm going to use scissors method for this one. 2x squared plus 13x plus 11. So you just need to think, how do you get 2x squared? Well, 2x times x, right? And how do you get 11? Well, you get 11 by multiplying 11 times 1, right? If I cross multiply these things, the answers that I will get are 11x, and in here I will get 2x. These two combined will give me 13x. That's the goal, to obtain the one in the middle. If it works, then you know that the factoring process would require you to use two parentheses. 2x plus 11, one of the parentheses, and x plus 1 in the other one. I'm going to explain how to find the factors of the other polynomial, because I assume you should be able to do them. But the first one, usually scissors method, is complicated for some people, so I need to explain that. So let's see. The factorization of the first polynomial will be 2x plus 11 times x plus 1. And the other polynomial, if you factor it, it will be, well, to get negative 2 will be minus 2 times 1, because minus 2 times 1 gives you 2, and minus 2 plus 1 gives you minus 1. So those will be the numbers, x minus 2 and x plus 1. Now that we have these things, we are going to have to do the step 2. We're going to have to multiply so that we match the denominators. Notice that in this first denominator, I don't have an x minus 2, right? So I'm going to have to multiply with the x minus 2 so that it also has it, so that it obtains it. And in this other denominator, I'm missing 2x plus 11, so I'm going to have to multiply with that one on the second fraction. So first fraction, I'm going to copy it, 2x plus 11 times x plus 1, and I'm going to multiply that with x minus 2, because that's the part of the denominator that is missing in that fraction. In the other fraction, I'm going to multiply these things with 2x plus 11, because that's the part that is missing, 2x plus 11. So multiplication of the first thing, 3 times x and 3 times minus 2. That will give me 6x minus, no, not 6x, 3x minus 6. Yes. On the denominators, we don't multiply, we only copy them inside parentheses, so it will be 2x plus 11 times x plus 1 times x minus 2. Plus, we're not going to multiply in the denominators, we're actually going to leave it like that, because in far ahead we're going to have to multiply. Cancel, in other words. 2x times 1 will be 2x, and 1 times 11 will be 11, divided by. I just copy them in parentheses, but the way I'm going to copy them in here is going to have to match the way I copied them in this place. Okay, so I'm going to copy them in the, trying to follow the same order of the first fraction. So I'm going to copy 2x plus 11 first, then I'm going to copy x plus 1, and then I'm going to copy x minus 2. There's no problem with this because the parentheses can be copied in the order that you want, so there's no problem with that. Once I copy them, you can tell that we have the same denominators, so we can add these things now. Okay, if we choose to add, it will be 3x plus 2x, which will be 5x as an answer, and minus 6 plus 11, which will be positive 5 as an answer. All of that divided by 2x plus 11 times x plus 1 times x minus 2. Yes. Now notice that we can factor the numerator. We can use greatest common factor and factor number 5. If we factor number 5 on the numerator, we're going to get x plus 1. So that thing, because it's repeating also on the denominator, can be cancelled, which is what we're going to do. We're going to cancel the x plus 1. That's going to leave us only with the number 5 and in the denominator the 2x plus 11 inside parentheses and the x minus 2 inside parentheses. So those two things, you're going to have to multiply them. So make sure you multiply them somewhere else. Okay, so like right next to the exercise you could put the multiplication so that you don't put it on a step and you only do the multiplication somewhere else. So 2x squared minus 4x plus 11x minus 22. That will give us 2x squared plus 7x minus 22. That will be the answer of this multiplication. So that's what I'm going to leave on the denominator. It's going to be 5 over 2x squared plus 7x minus 22. There's nothing else to simplify because I already simplified the 5x plus 5 that I got before. So that will be the final answer of this exercise. Okay. So all of the processes were used, all of the steps of the process were used in this exercise number 1. Now let's try to do another example. Okay. This one might be a little bit simpler, but it's still going to require all of the steps to be done. So let's try to do this. Okay. I can factor the denominators using GCF, or greatest common factor. I check what's repeating. In this case is the b that is repeating, so I'm going to take out the b and I'm going to have inside parentheses a plus b. On the other fraction I can factor also, but this time what's repeating is the a, so I'm going to take the a outside and I'm going to have a plus b inside parentheses. Notice that this denominator has an a, but it's not in here, so I'm going to have to multiply in this fraction with a. Now this other denominator has b, but the second fraction doesn't have a b on the denominator, so I'm going to have to multiply that one with b. So the first fraction is going to have to be multiplied by a, and the second fraction is going to have to be multiplied by b. So I'm going to multiply the first one with a. I'm going to copy the other fraction and multiply it with b, which are the stuffs that they are missing. A times a is going to give me a squared, and this letter at the bottom, I'm not going to multiply per se, I'm just going to copy it. Okay, so I'm going to copy it first, a, then the b, then the parentheses, because there's nothing to multiply with. We just leave it like that. Plus minus b times b will be minus b squared, and this b, once you multiply it, you're just going to copy it right next to the a, so it's going to be a times b times a plus b. Notice that now we have the same denominators because we did the step of multiply to match the denominators. We already matched them. So now what we're going to do is we're going to add a squared plus negative b squared. Because they're different letters, all I need to do is copy them. That will leave me with this answer. Now what I'm going to have to do is simplify the answer that I got of this addition. Can I simplify? Yes. If you factor on top, okay, because that's a difference of squares, you're going to be able to simplify. So a squared minus b squared, if you factor it, you're going to get a plus b and a minus b over ab times a plus b. You can tell that a plus b is repeating, so we're going to cancel that, and we just copy what is left, a minus b over ab. And that's it. We simplified already, so that will be the answer for this exercise. Notice how we have to do several steps in order to do these exercises. They are a little bit long, but the process is basically the same. Now this one. In this case, I have a fraction that is repeating up and down the same expression. There's a very short way of doing this, and I'm going to explain it at the end of the video. Right now, I'm just going to follow the same process that was explained before. Okay, the short version, or the trick that we can use in this type of exercise. You can see it at the end of the video. So I cannot factor, so I just need to consider the denominators. They're different. So because this one is missing m minus 2, I'm going to multiply with m minus 2 in here. And because the other is missing m plus 3, I'm going to multiply with m plus 3 in there. So those are the things that I need to multiply to make sure that I match the denominators. So this thing is going to be equal to the first fraction. I'm going to multiply it with n minus 2. And the second fraction, okay, I'm going to multiply with the thing that they're missing. The second fraction is missing m plus 3. It doesn't have it. So I'm going to multiply with m plus 3. So that both fractions have the same factors. If I multiply on top, it will be 4 times n for m, and 4 times minus 2, minus 8. Divided by, I don't multiply at the bottom, I only copy them inside parentheses. Then, on the other one, you perform these operations somewhere else, not in here, you do the operation somewhere else and you only copy the answer. The answer in this case will be m squared plus m minus 6. Do the multiplication on your own. You're going to see that's the answer. And the denominators, we don't multiply them. We only copy them inside parentheses, but in the same order as in the first fraction. So in this case, I'm going to put m plus 3 first. And then I'm going to put m minus 2. So I'm switching the order on how they are. Now I can tell that I have the same denominators. If the denominators match, then all I need to do is add. So m squared doesn't have anybody to be added with, so I'm just going to copy it. Now 4m can be added with m, so 4m plus m will be 5m. Negative 8 plus negative 6 will give me negative 14. And the denominators, I only copy them. Okay, I only copy them once. We already added. What we need to do next is simplify the answer. Can we simplify this? Yes. If we factor the numerator, we should be able to find something that can be cancelled. Factoring the numerator would give us m plus 7 times m minus 2. Why? Because 7 times negative 2 gives you negative 14, and 7 minus 2 gives you positive 5. So you can factor that thing that way. I copy the denominator, and I can see that m minus 2 is repeating in here. So I can cancel the repetition. Yes? If I cancel the repetition, there's only m plus 7 left. There's nothing to multiply with, so I don't need to put the parentheses. And there's only m plus 3 at the bottom. There's nothing to multiply with, so I can copy it without the parentheses. I cannot simplify anymore because it's already on its simplest form. So I'm going to leave it like that. That will be the answer for this exercise number 3. As explained, the process for this is a little bit long, but it's always the same idea for what you have to do. Let's see one more example. In this case, what I'm adding is not a fraction. So how do we solve this? Well, you just deal this thing as if it were a fraction. Like there's nothing on the denominator. So I'm going to have to multiply with the 2x minus 3 that is missing. And I don't need to multiply anything on the first fraction. So the first fraction is going to stay like that. And it's the number, the one that we're going to multiply with the denominator, so that they have both parts the same denominator. So I'm going to multiply with 2x minus 3 over 2x minus 3. When you multiply only a number, you just multiply up. On the denominator, you don't do anything, only copy the denominator of the other thing. So this will be 2x plus 1 over 2x minus 3. And 5 times 2 will give you 10x. And 5 times negative 3 will give you minus 15. Over the denominator, you just copy it. Now, notice that we have the same denominator, so that's going to be helpful. If the denominators match, that means we can add, so we just need to add 2x plus 10x. That will give us 12x. And 1 plus negative 15, that will give us negative 14. Divided by 2x minus 3. So we already added. Next, we should try to simplify. Now, can we simplify this thing? No, we cannot simplify it. We could factor this, yes, but if you decide to factor that thing, it's going to give you 2 times 6x minus 7. Now, that's not going to get cancelled with 2x minus 3. There's nothing that is repeating that you can cancel, so why are you going to factor if nothing is going to get cancelled? If nothing cannot get cancelled, then you're going to leave it like that. Yes, if there is no thing that you can cancel, don't bother in factoring if you're not going to do anything else after that. That will be the answer of this exercise. So with this we conclude the process of adding rational expressions. But remember, I explained that this thing had a different way of being solved, which was a faster way. So this is kind of like the bonus. Okay, let's call this a bonus process. Okay. How do you add these things? Well, first, notice that this has the same thing up and the same thing down. So imagine other examples, like 3 over 3. The same thing up, the same thing down. 2 over 2. 7 over 7. Okay? What do they all have in common? That they all are 1. Right? So this is a tiny trick that we can use. What you're adding in here is just 1. Because any number divided by itself is going to give you 1. So the trick is that when you have a fraction that repeats up and down the same thing, you can change it with any other fraction that repeats the same thing up and down. So instead of n minus 2 and n minus 2, I can change that with any other thing, like 3 over 3, or 7 over 7, or n plus 4 over n plus 4, whatever I want. I can change that with whatever I want as long as it's repeating up and down. So conveniently, I'm going to use the denominator. Why? Because that way the denominators are going to match. So I'm going to write 4 over n plus 3, but instead of this thing that you know it's 1 because you're dividing the same thing, you're going to put n plus 3 over n plus 3, because this is also 1. So you're not changing anything. You're still writing the number 1, right? But the cool way of writing this is that now the denominators match, so you just need to add. So the m doesn't have anybody to add with, so you just copy it, and 4 plus 3 will give you 7 over n plus 3. If you check the video, if you go a little bit, if you move on this exercise on the previous process, you're going to see that is the actual answer. But this time we found it in a really, really short way. So this process ignores the normal steps that we should do, but it allows you to solve this type of exercises in a very fast way. The only problem is it only works with these exercises. It doesn't work with the other ones. So if you don't have an exercise like this, you're kind of like wasting your time trying to do this. So have that into consideration. So with this, we would conclude the topic of addition of rational expressions.